Today we will talk about the second part of section 3.3, which is condensing logarithmic expressions. In the previous lesson we talked about expanding logarithmic expressions, taking a single logarithm, like log base 4 of 6x, and making it 2 logs, or expanding it. Today we are going to do the opposite. We're going to start with something like this and make it one single logarithm. So the first thing, if you want to write a logarithmic expression as a single logarithm, is to basically look at what is the operation between the two logarithms. In this case, the operation between the two logarithms is addition, so therefore, remember addition comes from the multiplication, so to go and condense it, we make it one single logarithm, but we multiply the two terms, so the 2 and the 32. 2 times 32 is 64, and then remember, if the number here, 64, is a power of the base, in this case 4, then we can simplify it, and 64 is a power of 4, it is 4 to the third, so therefore the answer is 3, because these cancel out. Here notice it's subtraction between the two logarithms, so you can you can divide, so you have 4x minus 3 over x, and that is it. There's no simplification that can be done with this one. You can also condense logarithms by taking the coefficients in front and rolling them back. Notice how this one has a 1/2 in front and a 4 in front. Because remember in the previous lesson, we talked about how if it was log of x squared, that you could take the exponent and roll it to the front to make it 2 log x. That's expanding it. Today we're going to do the reverse. We're going to take this exponent and roll it back. So we're going to take the 1/2 and we're going to roll it back onto the x. We're going to take the 4 and roll it back onto the x plus 1. Or x minus 1, sorry. And then the addition here means you can multiply. Now, the last thing that we're going to do here is take this x to the 1/2 and make it back into a root, a radical. So x to the 1/2 becomes the square root of x. And there you go. So the next example here, remember, first we'll roll everything back. So we'll roll all the exponents back. So we have the ln of x squared, and then we have the ln of x plus 5 to the 1/3. Then we'll take, because it's addition, and multiply them together. So we have the ln of x squared times x plus 5 to the 1/3. And then notice, because it's the 1/3 power, the fractional exponent will change it to a radical. So as a radical, it's the cube root of x plus 5. And there you go. So if you notice in part C, there's actually 3 terms here. So let's take them 2 at a time. But first, remember, just like we did before, we're going to take the coefficients and we're going to roll them back onto the logarithms. So we have log base b of x to the 1/4 minus log base b of 5 squared minus log base b of y to the 10th. Now we're going to take it 2 at a time. So we're going to look at the first two here, and because it's subtraction, we're going to divide. So we get log base b of x to the 1/4 over log, or over 5 squared, which is 25. Notice 5 squared is 25. Minus log base b of y to the 10th. Then, because it's subtraction again, we're going to divide. Notice subtraction, so we're going to divide log base b of x to the 1/4 over 25. Now, because there's a subtraction here, that means the y to the 10th is going to the bottom of the fraction. If it was plus, the y to the 10th would go to the top. Now, the only thing left to do here is to change the 1/4 from a fractional exponent into a radical. And that means that it's the 4th root of x over 25 y to the 10th. The last thing that we're going to talk about is how we would change the base. Of logarithms, so that basically we can do them on our calculator. Because remember, on our calculator, we just have log, which means base 10, and we have ln, which means base e. So to do the change of base property, to change a logarithm, you basically will take, like for example, if I had log base 7 of 10, I'll take the log of the number, which is 10, and divide it by the log of the base, which is 7. Or I could do it with natural logarithms as well. I could go log base 7 of 10, that would be the ln of 10, over the ln of 7. And that'll give you a decimal for your calculator. So, for example, if I want to use common logarithms to evaluate this, I would go log 2506 over log of 7 and if I type that in my calculator, log 2506 is equal to about 3.4, but I could just type it all in my calculator. Go log 2506 divided by log 7, and I should get 4.02. If when I type it in my calculator, make sure this is how you type it, with the parentheses and everything. Divided by log 7, like that. If you type it in exactly like that, you will get the answer 4.02. And basically what that's saying is 7 to the 4.02 power is equal to 2506. Also, you can do natural logarithms with the change of base formula. You could go ln of 25 or 2506 over the ln of 7. You type that in your calculator, and you get the same thing. It's 4.02. So there's two ways to do it. You can either do common logarithms or natural logarithms. You get the same answer either way. Please remember to fill out the questions, and this concludes our lesson for today. Thank you.